Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Today we are from PBL RKS-205 group. We'll present about our project called DDoS Defend Matrix, Simulation and Mitigation of DDoS Attacks on GNS3 networks. Before presenting, let me introduce our project manager and my team members. Here is our project manager, Mrs. Festi Windasari, and here is me, Raihan Julyandri, as a team leader, and there is my team member. There is Zanet, Aina, Udin, Dinda, Hafidzah, and Luqman. So the first thing we're gonna explain is about DDoS and DDoS Defend Matrix. DDoS, or distributed denial of service, is a malicious attempt to attack a server by flooding its traffic, making services unavailable. DDoS Defend Matrix is a framework used to model attacks and implement mitigation measures against DDoS attacks. In our project, we are implementing three types of DDoS attacks. The first one is SYNC flood. SYNC flood is an attack to make a server unresponsive by flooding system resources of excessive TCP SYNC requests. The second one is UDP flood. UDP flood is an attack that utilizes the UDP protocol by sending excessive UDP packets to flood the server with unwanted traffic, causing the server to run out of resources. And the last one is HTTP flood. HTTP flood is an attack to make a server down by flooding HTTP requests, such as GET requests or POST requests into the server.
The network topology that we create for this company has a clear structure, with division of access based on function on each floor. The first floor is reserved for the employee network. The second floor is the security operations center SOC, which is responsible for network monitoring and security. And the third floor is used as the DMZ network, which is a server where the company main data is stored and managed. The external network is not located within the company building, but is located in another location, such as a different city or country. The connection between the company internal network and the external network is done through the public internet, ensuring that outside user can only access service available online without being directly connected to the internal infrastructure. There are two connected to the cloud that serve as the main gateway between the external network and the internal network. The router connected to the cloud are configured with network address translation NAT that translate the private IP of the internal network to the public IP of the ESP, so that internet device can communicate with the internet. To improve network security and efficiency, we implement to company the risk of unauthorized access. In addition, we use firewall to monitor the network traffic and prevent threat from external network. In the attack simulation, we test a DDoS scenario where the SOC is in charge of ensuring that the incoming traffic to the server remains safe. This DDoS attack uses CNC as the main attacker, which infects other device into a botnet. This botnet then sends traffic continuously to the server, causing disruption or even downtime due to excessive load.
Okay, I will explain the tools that we will use to run the DDoS. In the tool, we use Python as a programming language. When the script is run, a display will appear as on the left screen. The tools we use, we call FloodX. FloodX is a tool for distributing DDoS created by our group. Here, you will be directed to select the type of attack, followed by entering the target IP address and the number of botnets you want to use. Next, enter the host address, username, password, and port number. If successful, you will be notified that the botnet is running.
Okay, so the target of our planned attack is a simple website that we built as a part of this project. This website was created for learning purposes and to test web security. At the moment, the site is still in the early development stage, and the only available features is a login page. It includes two input fields, one for the username and one for the password, along with a login button. However, the page is currently static. This means that the website is not connected to a database yet. The purpose of building and testing this website is to understand how security vulnerabilities can appear and how to prevent them in a real-world web application.
We present the tools and technology used in our project. We use Python as our main programming language to develop DDoS attack script, filtering mechanism, and anomaly detection system. The Linux operating system is installed on our virtual machine, functioning both as the attacking machine and the target server. Our network simulation are built on GNS3, which allow us to design, test, and monitor the behavior of DDoS attacks in control environment. In this slide, we present the division of tasks among our team members in the DDoS Defense Matrix project. For the program section, there are 3 members involved: Raihan Julyandri, along with Zanet, Evelyn, Zoly, and Aina, Hanifaturobani, Fath. They are responsible for developing and DDoS tools, implementing filtering script, and mitigating the system as well. Moving on to documentation, we have Fakhruddin and Luqman Baihaqi. They record every step our progress in the form of logbook and final report. Lastly, for networking and server tasks, we have Dinda Safitri and Hafidzah. They focus on Linux installation, GNS3 configuration, and ensuring the network communications run smoothly during the DDoS simulation.
Our progress we reach for now is 50%, that cover creating DDoS tools, building a topology setup, installing Linux, and analyzing the success of attack. And in our project, we found some obstacle from this project. The obstacle is the resource we use for virtual machine is not enough. Sometimes we cannot connect to GNS3. Sometimes the code stop working and cannot connect to botnet. Sometimes the botnet cannot attack. And the last is lack of understanding of some PBL target is to be archived.
Okay, so for this project, we divided work into 4 main stage, which is literature study, preparation, explanation, and analysis. This stage work 2025. Out of total 50% project progress, the literature study stage contribute 5%, resulting in RPP document. The preparation stage contribute 20%, involving software installation, network topology design, attack selection, and development of the target application. Next, okay, so for the attack simulation stage, at 10%, where we taste the plan of the attacks. Finally, the analyze stage contribute 15%, covering a review of challenge and completing of the output, including the project and presentation slide. Next, for the next step we plan to is integrate DDoS tool with the graphical interface and add a database server to the web server target for more realistic testing. Next, we'll create a script to filter traffic based on IP and bandwidth limit to detect and block a suspicious activity. A Python script using a queue will be built to log and track network anomalies in real time. Next, we will prepare a report that analyze potential security risks and suggest improvement. A simple firewall will be set up to control traffic and enhance server protection. And the last one will calculate the likelihood of detecting anomalies to evaluate our system effectiveness. Next, so to wrap up, we've completed the first half of our project from research to testing and analyze. Up next, we'll keep improving the system by adding new tools, making it more secure and preparing the final report. Thank you for your time and attention. We hope this presentation has provided a clear and useful overview of our project. See you. Bye.